let's do it. Okay, guys.
Way to
So
learn.
I'm Alex. I mean, you can actually see the first application of AI on the first slide. I mean, that's me with AI generated hair. And so like there is an application, again, I've been bald for like good 10 years now, and nothing grows on my head. And but like an application chose like 3 types of haircut which would suit me, and proposed, and I picked that one up. So yeah, AI in action. So who the hell am I? And so like I am a physicist by training. So I spent about 10 years in academia. From 96, I started early as a student, and then till 2006. At my last 3 years in academia, I also did 3 biomedical startups. And then I switched from the academic world to the dark side of business, and joined a software company as a VP of biz dev and sales, and did 7 years at a fairly small, just a couple thousand people company called Mera out of Russia. And then in 2013, I joined a pretty cool startup, computer vision startup called Itsees. And Itsees is, well, I mean, was a company which maintained and developed a computer vision library called OpenCV, which is de facto the standard in computer vision. So OpenCV was originally developed by Intel. The development started in late 90s, and then Intel carried it on for a few years. And Intel open sourced the library around 2006, 2007. Itsees was formed by a few ex-Intel guys, also out of Nizhny Novgorod, Russia, and they started Itsees. And I joined them like quite much later in 2013, and first as the CMO, and then eventually I became a co-founder and the CEO of the company. And in 2016, we sold Itsees to Intel. So it was a nice acquisition by a large company, and I joined Intel out of Itsees along with my team and along with the CTO. But we also had another company at the time called Itsees 3D, which we didn't sell to Intel, and it's still a thing. I mean, it's still a standalone startup company, and the company started off doing 3D scanning, and now the focus of the company is avatars from a photo. Essentially, you snap a photo, and then Itsees 3D creates an avatar, like 3D avatar with and it does the full body rigging and stuff. So I have been at Intel since 2016, and in 2021 became general manager for Intel Russia for R&D side. And then, I mean, Intel shut down its operations in Russia in April of 22. So I moved to Dubai and have been running Intel's R&D in Dubai since then. So I mean, that's who am I. And like before we get to AI, and I want you to think why we do things. And so when I was in academia, so I joined a very cool lab when I was 20, and when I was on my 3rd year, and I got involved into very interesting stuff, and we were building early cancer diagnostics tools. And but for me, the reason why I left academia was that I kind of learned along the way throughout those 10 years that you may work on something for many, many years, and there is a fair chance the stuff you are building would not see the light of the day, and so it would not get into anybody's hands. I mean, people would not use your stuff, so it would be essentially purely theoretical exercise. I mean, humanity would not benefit from that, and to me, it was quite scary. And I was young, and I wanted stuff which I create, I wanted that to benefit humanity. I want people to use it, and I want stuff which I work on to be, well, I mean, used widely. And and that actually sometimes research and industry goals are quite contradictory. And and especially in AI right now, we see a lot of things which are done just for the sake of doing things. I mean, there is no application in mind when people design those deep learning networks, and they like fantastic amount of AI stuff is built just because people can build it, so not because somebody needs that. And I have been, again, from early years in academia, I wanted stuff to be useful, I wanted stuff to be used by people, and therefore again, you guys are all studying right now and learning things, and but I think it's pretty smart to think of what you want to build before jumping on to building a technology. Think of the end application, think of the use case, and think of the end goal of what you want to build. And so there is a very famous customer experience YouTube video, and when Steve Jobs says that you have to start with customer experience and work your way backwards towards the technology, not the other way around. And quite a lot of things in AI these days is, let's build a network, let's train the network, and then think about applications. So the ultimate measure of technology success in its real life applications. So that's why we do things, and I think it's an important concept to carry on in your life, unless you want to be like a theoretical physicist, and unless you want to study black holes and gravitational waves. I mean, even in gravitational waves, I mean, they have LIGO, which allows you to detect gravitational waves. So, but think about what you want to build, and then work way back and choose a technology for that purpose. So I'm not gonna spend time on the video, so you can watch that. And so machine learning has been around for decades, and it's been used in, for instance, machine vision in factories for like 30-40 years. So the AI as a term was coined back in the mid-50s of last century, and at Dartmouth conference, and then, I mean, there are different periods in whole AI revolution / evolution. So there are very productive periods, and there are so-called AI winters, and some people define the start of the next AI era in 1998, when Jan LeCun proposed LINET for optical character recognition. And I think that it would be more accurate to define the start of the next AI spring in 2012, and that was introduction of AlexNet and the introduction of deep learning networks. But essentially, when we look at machine vision or deep learning, or in more general terms, AI, so you have data coming into your system, you analyze that data, but the goal of the whole thing is to get business insights, and to make certain decisions, or act upon that data. And so therefore, everything we do is for business insights, and everything we do is for doing something meaningful. And so, like, for me personally, after working at its and on OpenCV, so democratization has been very important topic, like personally in my business life. So OpenCV was Apache 2.0 open source. So essentially, it's available to anybody, and no royalties, no poison pill, and fully commercial. So therefore, anybody can take any part of OpenCV and add those algorithms to their own products and go sell that software and monetize it anywhere they like. And so therefore, I believe that AI, in the very same way like steam engine was the foundational mega enabler for the first industrial revolution, and the internal combustion engine was such a thing for second industrial revolution. AI is a technology mega enabler for many industries like computer vision, natural language processing, drug discovery, and like the talk of the day, Gen AI and LLM. So therefore, I think it's when I look at the whole landscape of software development, and roughly we have 22,000. I mean, let's just for the sake of the argument, let's say we have 30,000 highly trained AI researchers and aficionados. I mean, those researchers create new deep learning topologies, and those would be the guys like working for OpenAI and working in DeepMind and like software developers at the very forefront of AI revolution. And then, I mean, we have 10x more AI practitioners, and I personally think of myself as an AI practitioner. And then, but you have 100x more just simple developers. And when I think about democratization of AI, and I think of us bringing AI goodness to 30 million software developers, and those 30,000 researchers and aficionados, I mean, they have everything. I mean, they know everything, and they don't need any help. Practitioners, so the tools for those already exist. But like the ultimate goal of AI proliferation would be to create proper tools and simple tools, sometimes even low code or no code tools for 30 million of software developers. And the benefit of that is going to be in well, actually using AI properly, because typically when you limit technology to a few people, even very smart people, and they have very limited range of applications they can propose. And when you get all that goodness in the hands of many, and it's when magic starts happening, and it's only when those many will find those end applications, those killer applications. And so therefore, I mean, without proper democratization of AI, I mean, we cannot expect AI to be all present in our daily lives, and we cannot expect to find out all those important applications which AI can benefit, and like in the end, I mean, humanity can benefit from the full power of AI. So therefore, like democratization is very important. And so like if I were to quickly summarize what's needed for those 30 million, I mean, they need access to open source AI models and data. And by the way, Hugging Face already provides quite a lot of that. So it's Hugging Face became sort of the GitHub for models and for data. So I love the company. I know quite a few leaders from the company. So I admire what they do for the democratization of AI. And we also need to be able to run or infer those AI models on desktops and laptops. And I'm not sure if you saw that meme and like GPU poor people. And but I'm sitting in front of a laptop right now, and it's Lenovo And it's, again, I don't have a beefy GPU sticking out of that laptop. I mean, there's probably a like small embedded GPU in it, but I still won't be able to run AI models on it. And we also need, as users, we need to be able to create our own models using our own small data sets without going through very complex and, well, quite expensive training procedures requiring too much data, something we don't have. So I mean, that's what we need as users. I mean, that's what we need to give those 30 million of software developers. And once we solve that problem, I mean, that's what we need to give those no-code and low-code tools actually to many more subject matter experts, I don't know, farmers, and who want to use smart agricultural robots for killing weeds, for instance, or for honey makers, and when they control the population of the bees with cameras. And there are many applications, and creating those tools and making access to those tools easy and unburdened. I mean, that's the ultimate goal of what we should do. So, and briefly, like if I were to look back 10 years ago, and everything was proprietary. I mean, training frameworks were proprietary, deployment tools were proprietary, data was proprietary. And if I jump to where we are right now, so training frameworks are open. I mean, TensorFlow, PyTorch, Battle, so totally open, totally available. So when it comes to deployment, I mean, we still are seeing a mixed bag of things. I mean, so TensorRT is by NVIDIA is closed source, or in the next runtime and OpenVINO, both open source, and but data continues to be proprietary with few exceptions. And as a matter of fact, I mean, the deep learning topologies, except for, I don't know, GPT-3, GPT-3.5, and GPT-4, and Claude and Gemini. So there are a few closed source ones, but for instance, in computer vision, everything is open source. And so within a few years, stuff becomes open source and readily available. And so for the most part, I mean, data will most likely continue to be proprietary, and that's going to be a differentiating factor. But tooling is going to be fully open source, and deep learning topologies are going to continue being open source. And even when you look at the scoreboards for Gen AI and LLM stuff, and among those closed source proprietary models, there is Llama 2 by Meta, there is Mixtral, there's a few models from Mistral.ai company. So open source is slowly but steadily getting in the realm of, and well, becomes competitive with the proprietary stuff. So what we do as a team and what we do as a company for democratization is, so after the company was acquired by Intel, we joined Intel and we joined IOTG division. Now it's called Network and Edge division. And we build a product for deep learning model deployment. And again, fully open source, Apache 2.0 license, everything is on GitHub. We currently support the full range of Intel hardware, but we also support ARM. And when we are open to support it, other third-party hardware. So like the whole thing is open, and we are open to any kind of contributions from the outside world, and we welcome developers to join and co-develop with us. And essentially what OpenVINO does, it allows you to deploy a trained network on hardware, and it simplifies the path from a trained model to good performance on hardware. So you don't need to learn how to optimize, you don't need to learn how to, I don't know, write Ninja code, so how to distribute your network or your pipeline across multiple pieces of hardware. I mean, say if your system got CPU and integrated GPU, like OpenVINO does that for you, like load balancing, and so we take care of quite a lot of deployment specifics. So and out of the box performance is fantastic. So essentially, if you are a data scientist and you know how to train a model, and when it comes to deploying that model, you choose OpenVINO as a platform, and we take care of a lot of plumbing stuff. So we take that complexity out of the question. And so now let me jump and tell you about what actually happened in the past 10 years or so. So like AI renaissance happened in computer vision, and it actually happened under my watch. I mean, I joined ITSEAS in 2013, and so there was a data set called ImageNet, and then there was so-called ImageNet Challenge, and I like to call it the Olympic Games of computer vision. And in 2012, the group, I think from Toronto University, Alex and the company introduced AlexNet, which was the first deep net, I mean, multi-layer network. And it showed a drastic drop in the error rate. And I mean, ImageNet is 14 million plus images, 1,000 classes, and the task was recognition and essentially differentiation, cats and dogs, and so on. And so an AlexNet dropped from roughly like 26, 28% for the previous 2 years to 16. Huge drop. I mean, and then once the concept of deep neural net was picked up by researchers, within the next 2 years, deep learning nets beat humans. So human error is a little under, I think, like 4% or so. And by 2015, ResNet, very deep ResNet with 152 layers beat humans. And then starting from 2016, like the competition became like turned to ensemble of networks, and it was not a single network anymore. It was multiple networks and combinations of networks. But essentially, within 3-4 years, CNNs, convolutional neural nets, beat humans in accuracy. And so that was actually when true renaissance of AI happened, and it happened in computer vision, and I was there to see that. And so I feel, well, a little bit proud, to be honest, because that happened in my industry. So okay, so we beat humans in like 2015, and but what's interesting, and I find it truly astounding, if you ask me, is ImageNet challenge continued. And so right now there's probably there's more than 1,000 entries in ImageNet scoreboard. And as of December 23, about a month ago, they had like 951 entries. And they add roughly a couple hundred each year. And they are fighting for literally 1%, 1.5% of accuracy improvement. And if I were to look and compare like first 3 years of ImageNet competition, so the heaviest network in the original scoreboard was VGG19, and it was heavy, and it had very poor informational density. So essentially, it was large and very large size-wise and heavy compute-wise, but the accuracy which it delivered was not great as compared to its size and its heaviness. So, but the networks which compete right now, more than an order of magnitude larger than VGG19, and 2 orders of magnitude heavier compute-wise. So, I mean, if you ask me, so that's a pretty artificial competition. That's an artificial challenge, and every entry is a piece of work. And essentially, it's probably a postdoc or a couple of students working on a new concept, and playing with data. So it's a substantial amount of work goes into that. And if you ask me, I mean, that is not very well placed investment. And so probably some of that work ends up into something interesting and productive, but more than 90%, I mean, largest chunk of that work just goes wasted. And if I were to briefly look at what actually industry needs, I mean, the industry needs smaller networks and lighter networks. I mean, smaller memory-wise, lighter compute-wise. For the most part, I mean, computer vision needs to happen at the edge, and so therefore, I mean, you have fairly constrained systems to run those networks. So therefore, like what the research world does and what the industry needs, those things don't overlap much. And if I were to summarize briefly, like what we saw in computer vision is, so computer vision and AI in computer vision was driven mostly by academia, and all of fundamental computer vision problems were solved. I mean, image recognition, image like object detection and semantic segmentation. But I need to highlight that I personally observed excessive focus and enormous waste when it comes to research efforts and resources, and so too much energy was spent or like wasted on fighting for that extra 1.1% of accuracy, with total disregard to the size of produced networks and required compute. One industry needed light and small, and for solving real life use cases. And trust me, nobody needs to differentiate cats and dogs in real life. I mean, it's like it was a pretty artificial challenge. So what also happened like kind of in parallel with convolutional neural networks. So the next step was recurrent neural networks, RNNs, and they were applied for problems like activity recognition. I mean, you have a sequence of frames, and you need to guess what's happening. And so they looked at correlation and LSTM, but it didn't stick. And so RNNs, I mean, researchers and the industry played with those for a few years, but they did not deliver much. But what happened then, I mean, in 2017, and it happened in the industry, not in academia, there was a foundational paper by Googlers, Attention is All You Need. And they introduced a totally new approach called transformer. And then, I mean, and that took the industry to the next level. And like CNNs solved most of computer vision problems, and transformers solved NLP problems, and now transformer is foundational for Gen AI and LLMs. I mean, it's the most important architectural block of that part of revolution, AI revolution. But right now, I mean, transformers are making their way into computer vision as well. And so it's 2017 was very important for the whole AI thing. But before I jump to image generation and stuff, Gen AI, I want to point out to a few very important wins because of transformers. I mean, those wins are not talked much about. But in 2020, using transformer architecture, the team, DeepMind team from Google, solved the 50-year-old protein structure problem. And so they predicted the structure of a protein within the width of an atom. And 2 years later, DeepMind published protein structure predictions for nearly all proteins known to people. So that is huge, but I don't think it resonated much. I mean, it is a fantastic result, which opens up a lot of possibilities for designing new drugs and for understanding disease. And just keep in mind that Transformers and Gen AI LLM isn't like, it's not only about generating dogs and cats and just talking to the LLM. So another interesting application and of Transformers is drug discovery. And when you have a chance, I mean, go Google in Silicon Medicine, and that is a fantastic new type of a drug discovery company. So they use AI in a very smart way, and so they created a few tools, and I think one of them is called In Clinical. They have like two more AI-based things. So they use AI to create molecules to like predict which types of molecules would work best for certain diseases. And then they use prior knowledge from multiple clinical studies, and they created a tool called In Clinical, which allows you to tell if going from limited to mass clinical trials in humans is going to make sense. And In Clinical allows you to predict if your most expensive part of clinical trials would probability of a positive outcome, and they can predict that probability with almost 80% accuracy, so which is fantastic. And say just for the sake of let me illustrate that by saying that typically standard pharma like Pfizer and the likes of Pfizer spend up to $500 million to actually create a drug, do limited studies, and then do a fully blown clinical trial. And in Silicon Medicine said that they could do the very same thing and they and spend like up to $5 million, so 100x less. And so again, AI is getting into very interesting fields, and but if I were to look at the fields where the impact of AI would be the largest, it would definitely be something medical, in my opinion, and because there's 10,000 plus diseases which don't have any cure, simply because like population of people with those diseases is just too small. So big pharma does not create any cure for them. It's just, again, if you have 1,000 people with a certain rare disease and you need to spend like $500 million to create a drug and then another few billion to market the drug. So no way, I mean, big pharma can create something for like reasonable amount of money. And if, say, we cut the spending like by 100x, I mean, with approach in Silicon Medicine is using, it is possible to actually do targeted drugs for people. So, but very important result. And now let me jump to Gen AI and LLM. It's been around for about a year. I bet you all played with ChatGPT, so did I. But there's like the whole thing reminded me of like a big bang. I mean, it started off with OpenAI, and then it just blew out of proportion. I mean, you can do all sorts of text-related stuff, and you can generate images, you can do audio, video, coding, and all sorts of like data analytics, gaming, and as I described, you drug development, education, and so on. And interesting thing, like OpenAI had an OpenAI Dev Day 3 months ago, and so I'm not gonna spend too much time on it. Let me just point out so that they have 2 million developers, and within a year, and more than 90% of Fortune 500 build on OpenAI, and they have 100 million weekly active users. I mean, that's huge. I mean, that's huge developer adoption. And revenue-wise, so they don't disclose it, but they hinted at that. So like they are allegedly going to be making about $1 billion in 2024, and so the market cap is around 100 bill, so it's 100x multiplier. So yeah, so it's out of this world, so it's hype driven, and so I don't think it's justified, but I mean they were number one, and so let's see where it's gonna go. But what followed, like literally within a few days after the whole OpenAI drama happened, and Ilya Sutskever, interestingly, the guy who was born in the same city with me, Nizhny Novgorod, and so he partnered with the board, had Sam fired, Greg, the chairman, left shortly after. And the sequence of events was interesting. So like then Microsoft announced that Sam and Greg will be joining Microsoft to lead a new AI division, and then another couple CEOs, potential CEOs for OpenAI were introduced, and a few hundred engineers from OpenAI threatened to leave the company unless Sam is brought back. And then finally, what happened is within a week, Sam was brought back as CEO, and Mira Murati went back to being CTO. But man, I mean, a very dramatic week for the company, and I'm not sure. Like, so like too much drama, and I don't envy Ilya because I mean he definitely ended up on the wrong side of history, and if Sam is gonna, well, Sam already recovered from the whole thing, and I don't think Ilya is gonna recover fully after what has happened, and but things got really interesting for about a week. But well, what we are seeing actually in the AI community right now is quite interesting as well. And so there are three prominent AI groups, and there's a group for AI openness, and with Jan LeCun and Adrian leading that group. There's a group which is strongly for AI regulation, with Sam, Demis, and Dario leading the pack. And there's a group of AI, so-called doomsday folks, and it's Jeff Hinton and Joshua Benjo, actually AI pioneers and honest and well, sincere people, I think. So like they sincerely believe that the AI doomsday scenarios are true. And AI regulation group, Sam and Demis and Dario are trying to perform a regulatory capture of the AI industry. So they leverage AI doomsday professors, and they lobby the corporate world, they lobby the political world, and well, I mean, we already saw the New York Times lawsuit against OpenAI, and so Sam spent last year lobbying the Congress and asking them for more regulation, and but I cannot formulate it better than Jan LeCun did. So the rise of power hungry 1%ers who rob everyone else of AI riches is the real doomsday scenario. So essentially what he says is Sam and the others, I mean, they tried drawing excessive attention from the regulators to AI, and they tried throwing a regulatory moat behind them. And so therefore, I mean, they could actually slow down the others while continue to run the fastest themselves. And that actually creates unfair competition situations, so that they capture AI industry. And so it's like they create a monopoly, more or less, and so they don't they use regulators to beat the others in the head, so that the others would need licenses to create AI. The others would need to register the data centers, and if this data center is of certain power, I mean, you need to be part of some registry, and etc., etc. So like that whole thing, I mean, the whole thing slows things down, and slows innovation, and stifles innovation. So on the other hand, what we also observed, and in LLMs and Gen AI, so the networks grew out of control in the very same fashion they did in computer vision. I mean, it started off with fairly small networks, then they grew more or less exponentially in computer vision, and then finally sanity kicked in, and the same happened in Gen AI LLM. I mean, they started off with 7B networks, and then 13, 40, 180 billion parameter network by TII Falcon, and then right now things are trending towards 7B and 6B, and actually there are some networks which are around 1 billion parameters, and so it's like sanity is finally here, and but while in computer vision it took like 4 or 5 years, and Gen AI LLM domain, the whole thing took a full swing in under a year. So which is interesting. I find it that interesting. And another trend which is happening in Gen AI and LLMs is privacy and security issues are causing a lot more interest in running inference locally, and using open source LLMs. And a few leaks with ChatGPT, when proprietary data from one company, I think it was like Samsung or somebody, used proprietary information from Samsung in a request to ChatGPT, and that information popped up in somebody else's response. So sort of a cross leak of information. And so when you have a proprietary LLM running somewhere in the cloud, you got no control of what kind of data was used to train that network, and you don't know for sure if the stuff you're feeding into your own session does not get stored somewhere in the cloud. So therefore, I mean, when you actually build your own pipeline using open source LLM for training and for inference, I mean, you can control everything. And ideally, if you can kind of keep your inference part at the edge or on-prem, so your data doesn't leave your premise, I mean, doesn't go anywhere in the cloud. So you just act upon that data locally, and it's actually the best case scenario if you do care about privacy and security. So when it comes to the edge, and we showed that Llama 2 the 7 billion parameter can be run on a laptop, and Intel introduced Ultra new core called Ultra, and back in September you can run, and it's very robust. I mean, it's I cannot read fast enough, so those answers just pop out. And so it is possible to actually, right now, I mean, it is possible to run moderately sized LLMs on a laptop, which is great. I mean, that's how you want it. I mean, that's exactly what democratization means. I mean, anybody with a laptop needs to be able to run all of those networks. Well, I have to show you those. I mean, So I did spend a fair bit of time generating dogs, and we have a cat and a dog at home, and we have a poodle. So I always generate poodles, and so those are my results, and all of those, maybe except, well, for that image, when a boy holds a poodle, all of those show something not realistic, something, well, I'm going to say that a little bit disgusting, and it's called uncanny valley effect. And so therefore, I mean, those Gen AI networks, I mean, they are good at generating stuff, but you can, in most of the cases, I mean, you see the 6 fingers or like 3 eyes, or like there are certain things which allow us to actually spot the true image, like live image from a generated one. And when it comes to video, so like when it first started in 22, they were totally ugly. And you can Google and look at original meta images by make a video. And but then Meta introduced EMU, and they actually do like look not incrementally, but a lot better. But still, I mean, you can find imperfections which immediately tell you that those are generated. So like uncanny valley effect is still present in those. So I think I personally, going back to my original statement, I mean, we need an application, and rather than technology first and then application later. So I think like copilots would probably be the first interesting application which is going to stick. And there are a few. Like there's a GitHub Copilot, and there's a Code Whisperer by AWS, and Google launched its Copilot in September, and Microsoft announced its Copilot also in September, so like very close. And I think Microsoft is going to make it a part of Microsoft 365. So like Copilots, well, a few Copilots on the horizon, and a few Copilots already in testing. So we'll see, and what from the variety of applications is going to stick. And but I like, before we jump to other stuff, I want to point out. So okay, so it's not all about like generated dogs and cats and doing Q&A with a laptop. So LLMs are finding their ways into, for instance, telecom, and the next big thing. And so if I were to look at 5G network right now, again, T-Mobile or whatever, AT&T, so roughly 75 to 80% of the money they spend is power bill from the infrastructure, from base stations, and they want to apply LLMs to do active adaptation of the network, active power control. So essentially, you may train an LLM, specific LLM, telecom LLM, using telecom data, and use that LLM to optimize power consumption. So if you can cut like 25% of power spending in the telecom globally, you would be looking at tens of billions of dollars in power saving. So there are very interesting applications for that. And when I don't want to spend too much time on creating your own LLMs. I mean, you can Google that and look it up. And I'll just jump a little bit further. And let me briefly talk about AI issues. I mean, we have like 7-8 minutes left. So the current LLMs are auto-regressive by nature. And there are certain things they're okay, like writing and coding assistance and stuff like, okay, draft generation, and you can do stylistic polishing and stuff like that, but they are not good to produce any factual information, and they hallucinate. I tried it myself. I mean, when I first got access to ChatGPT, I asked ChatGPT, like, if I would from which university I got PhD from, like 5 questions like this, 5 different answers. And so they all LLMs have information cutoff date. So essentially, they are not retrained, and again, you feed them information up to like August of 2022. I mean, that's all they know. So now all the stuff which happens after, I mean, they simply do not know. There are ways of giving them up-to-date information, but intrinsically they do not know that stuff. And so they cannot reason, and they cannot plan. I mean, they are not great at math. And I actually like to think of LLMs as of so-called stochastic parrots. I mean, I never had a parrot, but I saw a few parrots who could talk. And they, like, it's impossible to differentiate. I mean, the parrots are fantastic at replicating sounds. I mean, they can speak sentences, and it sounds totally like a human. But do parrots know what they're saying? I mean, do they understand when they say a phrase? I mean, do they understand what that phrase means, or they simply replicate like a sound wave? And in a way, LLMs are very much like a stochastic parrot. So it's they do not know what they are saying. And Jan LeCun, AI pioneer, has been saying about that fundamental problem of LLMs and their autoregressive nature. And he believes that the current architectural makeup of those LLMs is not going to let them to be widely used and widely useful. And and he proposes so-called objective-driven AI systems which can actually not only learn, but remember and reason and plan. So like, so therefore, I mean, what we currently have, it produces interesting results, but it's not a final answer. I mean, it's not artificial general intelligence in any kind of way. It's not sentient. So, and when it comes to AI legal landscape, I mean, things are interesting. And in 23, a few deals were made. I mean, Microsoft invested in OpenAI, AWS invested in Hugging Face and Anthropic. And what was interesting is all of those legal arrangements were arm's length, meaning if anything were to happen with OpenAI, so essentially it was OpenAI's problem. I mean, Microsoft wouldn't be touched. And but then, I mean, both OpenAI and Microsoft introduced well, I mean, they told the enterprise customers that they would be with them should somebody try to sue them. So, which was interesting move, because my original interpretation of the why they actually said things like that was, okay, so OpenAI gets in trouble, it gets thrown under the bus, and they pay the fine, but I mean, they cannot spend more than they have in the bank account, and we are talking like, I don't know, a few $1 billion. And so while Microsoft is a humongous company with very deep pockets, and they are trying kind of to keep the risks away from the mothership, but I think it was too obvious. So therefore, I mean, they try to get a little closer to the developers and introduce those commitments towards their customers. Well, very briefly, like probably a couple of minutes on the hype. I mean, the hype is toxic, and it's a poison pill. And in the beginning, like when 10 years ago, I mean, there was not so much hype around computer vision and how great deep learning and AI was to solving computer vision problems. And then for Gen AI and LLM, I mean, that hype was something else. And it just was extreme. And but because of that, again, on one hand, I mean, it simplifies raising money for startups. I mean, all you need to say is like, you're working on LLM, and the checkbooks open and you get as much money as you ask for. But on the other hand, you need to show something for that money, and so expectations are overblown as well. So, and because of the hype, right now we are seeing excessive scrutiny and excessive regulation coming towards AI field. So like there are some pros, there are some cons, but in my opinion, I mean, excessive hype brings more issues and problems than good. So, and the regulation landscape, again, it's unfolding in front of our eyes. I mean, Europe had GDPR, which was not AI related. It was more about privacy. The whole 2023, Sam Altman and other AI players were urging for AI regulation, and there was an executive order at the end of October of last year. EU had the AI Act in December of 23. And so like regulation is coming. The most troubling part is they do not differentiate between development and deployment. While I wholeheartedly agree that deployment of AI needs to be regulated, and development of AI should not be, and because regulating development will most definitely stifle innovation. So, and but let's see what's going to happen. I mean, we are already seeing issues, and we are already seeing lawsuits. As I said, I mean, New York Times is suing OpenAI for using copyrighted materials. So I don't think we have time for the sustainability topic, but something, again, I'm going to send the slides. I mean, have a look. So it's scary how much carbon footprint AI creates right now, and it's not slowing down. If anything, it's growing exponentially, and we need to be mindful of that problem. So AI and training those humongous networks, I mean, it's very, very well, bad for the planet, and so we need to be creating new environmentally friendly power sources, and nuclear should be back in fashion. And so if we use coal to power the AI revolution, I mean, we won't have a planet within probably, I don't know, 10, 20, 30 years. And so like, I think in summary, and again, you guys are young, I mean, you are learning, and focus on important real life problems. I mean, don't get stuck on artificial challenges. So we waste too much effort, too much money on scoring and actually 0.1% on a dashboard, and work your way back from the problem to the technical solution and underlying technology, not the other way around. And AI is, there's way too much hype around AI, and there's way too, it's not a silver bullet. I mean, there are other technologies. For instance, AI is not any good for time series data still. I mean, statistical analysis and like all the 10, 20 year old approaches work better than AI. And share as much as you can. And so data sets, topologies, retrained models. So that in that way, I mean, you actually save the environment, because if 5 people are not going to retrain the same topology, and if they just reuse yours, that's fine. That's good for the planet. And avoid hype at all costs. And hype is toxic, hype is poison. And I've been fighting hype as much as I can, and so help me with that, and be mindful that hype is not doing anybody any good. So Alex, I'm a little over the time, and I guess I'll stop sharing and take maybe a few questions.
Yeah, no worries. Let's give Alex a round of applause. So let's take a couple of questions. You can just raise your hand, I guess, and then yes, we can go ahead with that. So any questions for Alex? Yes, we have.
One question. Thank you for the presentation, by the way. Speaking of consumer grade AI compute, do you think that Intel or any other companies will start to release more like external AI ASICs like the Intel Movidius or maybe the Google Coral?
Oh, so
is
like
that
I knew my videos. No. So like I knew my videos before they got bought by Intel, and I knew everyone. I mean, Remy, who was the CEO, and Farshid. I mean, I was friends with all of those people, and yeah. So essentially, the laptop demo which I showed you, like Llama 2 demo, it got my videos chip inside of the laptop. So it's a part, it's an accelerator, yeah. So like Apple got M1 and now M2 chip with AI acceleration inside. I mean, my videos chip, which was a USB stick, like M2 and then an X, Myriad X. So that technology went into the laptop. So yes, like once those are out, and it should be any week now, any month now, and so you are going to be able to use that technology inside of those laptops.
Wow. So you think that maybe these ASICs might start moving inside of all the devices that we have?
It will happen. If we want to do stuff at the edge, there will be ASICs at the edge, and I believe like as okay, granted. I mean, there are certain applications which cannot be done. Say, I mean, you want to do multi-camera tracking, right? So you cannot do multi-camera tracking on one camera. So essentially, you need to bring some metadata to say, I mean, you want to track a person through the airport. I mean, you need to bring metadata from multiple cameras to the server, which is aggregating multiple cameras for the airport. So, but I mean, you're not going to be bringing video up to the server. You are going to be bringing metadata like embeddings of how people look like, and we call it re-ID kind of. So you bring a vector with the parameters, and then you track that vector of parameters across multiple cameras, right? So, but as much stuff you need to do at the edge as much as possible, because I mean, simply enough, there are not enough bit pipes to bring everything to the cloud. So
when it comes to like,
there's another one.
Yeah, thank you for the talk. In terms of high compute edge, is there a different kind of computing paradigm that you see coming to cloud or AI in general that can handle real-time AI inference? Well, one of the I'm looking at is neuromorphic computing, for instance.
Yeah.
Are there things like that that Intel has been working on, or things you have experience about?
Well, Intel is one of the big neuromorphic players. I mean, we have Lohi, and I think we are on the second or even third generation of neuromorphic. So neuromorphic is definitely interesting, and it's definitely different than deep neural networks and stuff like that. So neuromorphic is interesting. There was another thing by MIT called liquid networks, I think. So like the new approaches are happening, and it's not a done deal. And what's happening in AI and deep learning is heavy. It's not human-like. And so like the example which I love to use, and is you know about adversarial examples, right? And when you can buy a sweater, you put it on, and you are not seen by the camera. And another thing is like you have a photo of a panda, you mix some subtle noise in that photo of a panda, you show the same panda to the camera, and it tells you it's an airplane, and like adversarial noise. And so essentially like CNNs or RNNs, and it's not human-like intelligence. I mean, that's the large chunks of data, and but it's not how we learn. It's not how we humans operate, and so therefore neuromorphic is more human-like than AI right now, and it's like auto-generative nature of LLMs right now and the hallucinations. It's gonna be hard to totally get rid of that. I mean, they hallucinate, and it's unavoidable. It's not a bug; it's a feature of LLMs. I mean, that's how they're made up, and they do. I mean, they produce interesting results, and I don't think those can be used widely without human in the loop right now, to be honest. But let's see what happens. And we LLMs and Gen AI, they need to find the paying users, and they need to find those killer applications. And right now we are at the tipping point. I mean, the technology, massive investment in technology, and now those investment need to start generating money, and we'll know soon enough where that stuff sticks. Essentially, I mean, the spaghetti is on the wall, and now we need to wait probably a few quarters to where that spaghetti sticks, right? And otherwise, I mean, if it's all on the floor, I mean, those investments are gone, and it was all done in vain.
Let's take one more question if we have one.
Yes.
Maybe if anyone else has a question. If not, then I mean,
What's your question?
rock, paper, scissors.
I was asking about large action. I'm curious, I don't know if you got the ads. I feel like it was pushed in everybody's face about the Rabbit R1, talking about large action models, and it's something I'm looking into. I don't know if that's anything that you have like special information on.
So large action models, I mean, I am not familiar with those. I mean, what are those?
Basically, instead of communicating through language, the response from an agent would be a set of actions. So you're not getting text responses back. You would be getting, say, like you ask a chatbot to book you a flight, instead of saying, okay, here's the Expedia flight for this much and this much. It goes through the the user flow, like basically be a human, and books you the actual flight for you. And I think there was like there's this discussion about how you can stray away from LLMs and go to this large action model framework where you're dealing with actions.
No, but it's I think it's just one step further. Like you can ask LLM generate me an action plan, and but you actually take what LLM spits out, and you just plug it into well, I mean, you take it one step further. So essentially, if you have a plan, and you can ask, there are travel assistants, and I actually know a couple of startups myself. I mean, they create travel plans, like customizable travel plans, but I mean, they tell you need to book that flight, and instead of you going and booking that flight, I mean, they do it for you and by some sort of API. I don't think there's anything magical happening here. I think they just take the LLM output, parse it, and use it as input for other systems.
Well, let's give another round of applause for our speaker.
Well, thank you so much for having me, guys, and I hope it was useful for you. And yeah, Alex, you know where to find me, and so happy to do another session if you like. Happy to send somebody with OpenVINO if you guys want to hear about OpenVINO.
Definitely, 100%. We'd love that, and we'll send out the presentation to you guys as well as the Zoom recording, so you can look back at it if you wish. But thank you all for coming, and thank you, Alex, once again presenting to us. It's truly a pleasure.
Yeah, thank you so much.